What is motion? It is known in history that, many centuries ago, a now legendary scientist by the name of Isaac Newton also had this question. However, instead of retelling the age-old story of the apple falling from the tree, I want us to instead opt for cutting straight to his result. You see, it is because of his pondering upon the universe that we now have what physics refers to as Newton's laws of motion. Newton's laws are often accepted as postulates, at least in the realm of academia. But then you may ask, what exactly is a postulate? Well, in the structure of science, a postulate can be defined as something assumed to be true without proof. Now, just because a law is assumed to be true, that does not mean that it has to hold up in all cases. To be more specific, a postulate can be thought of as a statement which tries to encapsulate something, usually a simple idea, which is self-evident, obvious, or generally accepted. For instance, Newton's first law. Newton's first law states that an object in motion remains in motion with constant velocity unless acted on by some external force. Using this postulate, we can now easily begin to understand how an object changes speed and direction after having accelerated into motion. Similarly, the first law also states that an object at rest will stay at rest unless it is perturbed by an outside force. We can imagine this variation quite easily through observing a field with a standing tree. Notice that as our tree stands, its branches are only disrupted a tiny bit by the wind forces which try to move it from where it rests. However, always remember the key takeaway. If a force is strong enough, anything at rest can easily be set into motion. Having fleshed out our first principle a bit, I would like us to now touch upon our second law. Among physicists, Newton's second law is most often stated as the equation F equals ma. However, for the purpose of our lecture video, allow us to speak a bit more plainly. You see, the second postulate states that the amount of force a given mass experiences is proportional to the amount of acceleration it undergoes. If one is keen, you may have already noticed that the terms acceleration and velocity have not been clearly defined within the self-contained context of our video conversation. Please know that I have done this intentionally. In doing so, I am allowing us to immediately jump into the world of scientific derivations within our homework files. These derivations shall prove to be rather rigorous, but the results will be some of the most fun brain games you may have ever seen, at least in the world of humanity. Through completion of such mental games, we will be rewarded with understandings of the secrets of our cosmos, a prize truly fit for fellow kings and queens. However, I digress. Jumping back on topic, the second law attempts to couple the force an object experiences to its apparent acceleration. This implies that if we are able to measure how much an object's velocity changes, maybe through the use of high-fidelity cameras and simple maths, then we may in fact be able to tell how much force was applied to the original mass in question. In fact, such a tool becomes nearly indispensable when trying to understand collisions, projectiles, and many other natural phenomena which underlay our entire world. Now, last but not least, Newton's third law. The third law states that every action possesses an equal and opposite reaction. Said simply, when two objects are interacting, take for example a cue ball and a pool stick, the force that each one object exerts on the other is often thought of to be equal and opposite. However, when there is more than one object involved in a collision, the forces tend to distribute equally amongst them as opposed to focusing on just a single one. Now, this insight might seem rather elementary at first, but I assure you that the results of this principle are nothing short of groundbreaking.
All systems are go. We're about 90 seconds to launch a special.
Without knowledge of Newton's third postulate, it may have never been possible to create the mechanisms necessary to propel mankind into the space age centuries later. Heck, no third law implies that humans would lack the foundation necessary to understand the power of splitting an atom, and as a consequence, we would never have developed the technology for nuclear energy. These three laws supply the roots for our basic understanding of physics. though roots alone will not be enough to get us to the realm of the quantum.
Be advised, assailants are armed and dangerous.
To say it outright, there do in fact exist other forms of physics, or mechanics if you will, which supersede our Newtonian postulates. The first instance, at least to my knowledge, of an alternative view on physical systems was developed in the late 1700s by the late Joseph Louis Lagrange. It was given the name mécanique analytique, which translates to analytical mechanics. The full details of this topic shall be saved for a future video, but for now, knowing that new systems of mechanics can easily be created, why don't I leave you with some more advice, similar to last time. Octonions are easily understood through the lens of a division algebra. However, such a topic can appear quite advanced for the budding physicist. Do not allow this to hinder you. Look for a man by the name of Dennis Morris. I believe that he will have more of the answers that you seek. For now, we must part ways again, but know that we will see each other very soon. Once again, we find ourselves at the end of a conversation together. As is now tradition, I would like to perform a rather small recap to go over the topics we have just discussed. First off, we learned that a postulate is a proposed statement accepted to be true as a result of its obvious nature. Understand that this does not make the statement automatically correct. It only implies that whatever was said, if actually considered valid, stands as a very good approximation to explain what is actually happening. Next, we learned that Newton's laws of motion, or Newtonian mechanics, comes in the form of three postulates. Since they were explained in detail before, I won't give you the full explanation again, but do note that Newton's laws set the foundation or roots for all entry-level physics. Finally, after acknowledging Newton, I confess that there are in fact other perspectives in physics which allow a more detailed view of reality. Mécanique analytique stands as the first of such perspectives, in that it supersedes the ideas of Newton in a much more clever way. Future videos will cover such exact details, but for now, the specifics shall have to remain a mystery. And with that, our recap is concluded. Until next time, know that you are loved. You will always be enough, and that your life matters to me. Peace, love, unity, and respect. Astro Dan out.